Alright, so question 12 compared to question 11, a lot of similarities. Well, one vector, we're going to find the component form of all the vectors. We're going to add those up to get the resultant vector's component form. And with the resultant form's component form, I can do the Pythagorean theorem to get the magnitude and the inverse tangent to find the angle. But my picture is a little harder to make because it gave me a bearing and not an angle from a positive x-axis. So 400 miles per hour, 320 degree bearing. Okay, so bearing, if it doesn't give you directions, is always in the north line measured clockwise. So 360 would be all the way around, 320 would be almost all the way around, but 40 shy. So I would also throw those angles in there while I'm thinking of it. This is supposed to represent an airplane that is 400 miles per hour. Okay, so that's a little bit harder than question 11. I did think more about the angle that it's headed at instead of it just being told to me. And then as it reaches a certain point, wind starts blowing at a velocity of 50 miles per hour in the direction of north 70 degrees east. So start your second vector at the end of your first vector. And this one gives me directions. And the north line turns 70 degrees towards east. So this would be 70. And this is only 50 miles per hour. Probably should have drawn those a little more to scale. This is 400, 50 should be a little bit shorter. So you'll kind of see. I'm going to go ahead and show you. Okay, so this is where your airplane would be if you did nothing. This is where your airplane would be if there was no wind. And this is where your airplane ends up because there is wind. So this, I put in the black, is my resultant vector. Its magnitude is going to be the speed of the plane, and this angle is going to be the direction it's taking. Okay, so just like question 11, I can figure out how much this is pulling it west, figure out how much this is pulling it east, and I can add those together to figure out how much total of this guy is going west. It appears to be going west. So I can do that. This would be 400 cosine of something. This would be 50 cosine of something. And I'm leaving those blank for a moment because this is where you guys have lots of mistakes. And I tried to worry about this before the quiz too. I'm going to pass it back in a few minutes. 99% chance the angles you're supposed to put in here are not 70 and 320. It's very unlikely that a bearing just happens to be the correct angle. A bearing is a good way for us to measure directions in real life, but when I start throwing things into sine and cosine, your calculator only knows one way, and that's standard position. So you have to force yourself to look at the positive x-axis and measure clockwise. Here's the positive x-axis, or counterclockwise. Measure counterclockwise. Because that's how angles are defined when we did trig last semester. So the fact that I already thought about this being 40 helps me a lot because the quadrant's just 90. So 90 plus 40 tells me that's 130. Again, reread the question and notice nowhere in there does it say 130. That came from the positive x-axis measured counterclockwise, like all angles are in standard position. Okay, and then do the same over here. You can throw 70 in there if you want to, but that's the wrong angle for where it's really going. It was a north 70 degrees east bearing, which means my positive x-axis clockwise, counterclockwise. This is still helpful because I know all of this is 90. If this much is 70, then this much would be 20. Most mistakes are going to happen right there. That's where you guys need to slow down the most. Probably highlight your work in there. Or even probably that sentences. So this is how much is going to the left, and this is how much is going to the right. Adding those together tells me what's happening with the result of those two things. 400 cosine of 130 plus 50 cosine of 20 will end up being this thing. Okay, same logic for the vertical component. This one's going up, this one's going up. So I need to figure out how much this one's going up. And that would be 400 sine of 130. I get to reuse that angle. And this would be 50 sine of that angle. I get to reuse that. Add these together to figure out what's happening. It's take into account both of them. This is going to represent that distance. So you end up knowing 2 or 3 sides of the right triangle. So now we can use Pythagorean theorem to find the hypotenuse length, which would actually be the magnitude of the resultant vector, which is the speed of the plane. So I store all this in my calculator once. For x and y, that is cosine, the only part of the horizontal component, sine is the only vector trait, and the vertical component, that's always true, so that's a good check. Also, those are supposed to be the same except for sine and cosine, so that's a good check too. So, Pythagorean theorem tells me the magnitude of the resultant vector, which in this problem ends up being the speed of the plane, which of course would be of interest to us. And that number should make sense in the context of the problem. The plane was 400 miles per hour. The wind is pushing it back some to the right, so the wind's slowing it down some. It's just wind, so it's not going to make that much of a difference, but it does make about 14 miles per hour difference. Okay. And the other thing that we really care about is what angle is it making. So what direction is your plane going? Obviously you want to land at the airport and not somewhere else. So that would be like saying, what's the angle of a right triangle when they're opposite and adjacent? So inverse tangent of opposite over adjacent. And then sometimes you need to add 180 to this and sometimes you don't. Negative 57 degrees is in quadrant 4. My resultant vector is definitely not quadrant 4. It's going left and up. It's in quadrant 2. So this would be a case where you need to add 180. And it is flying at a 123.004 degree angle. Now, if you want to change that to a bearing, more power to you, but it doesn't say that you have to in the question. So why add an extra step and maybe miss it? Just give the English maintaining position. So comparing question 12 to question 11, we still did component form of both vectors. We still added them up. The resultant vector magnitude was still Pythagorean theorem. The direction was still inverse tangent. This one we didn't need to add 180, just based on what quadrant the angle was in. This one we did have to add 180, based on the quadrant that it was in. But what I have here in yellow is an extra layer of difficulty. It was not 70 that I plugged in. It was not 320 that I plugged in. Those were not angles from the positive x-axis. These were angles from the positive x-axis, so I can just plug them in. These I had to think about what it was from the positive x-axis counterclockwise 20, positive x-axis counterclockwise 130. You have enough information to find those, but it's not going to just be fly by two. Alright, any questions about 12?